we said the amplitude is the maximum displacement of a particle from its mean position, and so on and so forth. And from there, we look at the period, the time it takes for what do you call it, the time required for a particle to undergo one complete oscillation or something, or cycle, one complete cycle. We studied that. We also looked at the frequency, that is the number of complete cycles which a wave makes or takes in a second. We looked at the wavelength, which is the distance between the distance along the x-axis, that is between the successive crest or successive troughs or compressions or refractions. We looked at that the other time. We also looked at the speed or the velocity of the wave. That means the speed, the distance the wave travels in a second. And we looked at the relationship between the t, that is the period, the frequency, the wavelength, and the velocity. We looked at that, and we were also able to prove the progressive wave equation. And we said that when it is positive, then that means the wave is traveling from, or the particle is traveling from right to left. When it is negative, that means it is traveling from left to right. And I explained all this the other day. I also explained what the phase difference, or the the phase difference, or what do you call it, the lag on means, the angle, the formula for it. I said 2 pi x all over a wavelength. I remember I taught you the other day. So we looked at that, and we are left with questions to solve. I think about 4 or 5 questions we can solve. Then we do, and I also taught you that we also went a little bit through the properties of waves. We said waves can be reflected, that's the bouncing back when obstructed. We said they can also be refracted or refraction, as a change in direction as a result of the change in speed. We studied that the other time. We also studied the diffraction, whereby we said is the spreading of light when it travels through an aperture, or spreading of light waves. Let me put it, because we are doing waves, let me just use waves when it passes through an aperture, and so on and so forth. We looked at the interference. Today I'll be talking a little bit about the interference more. Then we'll do standing, stationary or standing waves, and we'll do differences between the progressive and the stationary. Then I think we do electromagnetic waves. That is it. So let's do some questions. So let's start. The speed of a radio wave. The speed of a radio wave. The speed. If I'm moving fast, you tell me. I was just moving fast because I was brushing through. So the speed of a radio wave. The speed of a radio wave is 3 by 10 raised to the power 8 ms negative 1. The speed of a radio wave is 3 by 10 ms raised to the power 8 ms negative 1. If a radio station broadcasts on a wavelength of 1.2 kilometer, if a radio station broadcasts on a wavelength of 1.2 kilometer, what is the frequency of the transmission? What is the frequency of the transmission?
So please repeat.
The speed of a radio wave. The speed of a radio wave is 3 by 10 raised to the power 8 ms negative 1. The speed of a radio wave is 3 by 10 ms negative 1 raised to the power 8 ms negative 1. If a radio station broadcasts on a wavelength of 1.2 kilometers, if a radio station broadcasts on a wavelength of 1.2 kilometers, what is its frequency of transmission? What is its frequency of transmission? What is its frequency of transmission? So are you there? So we know that the speed of the radio wave.
Yes,
You said, oh, you are trying it yourself.
yes, sir.
Okay, try it. That's ms.
So I'm stranded.
Okay, so let's do it together. So you have this, you are looking for this, but you know that you have to first change because this one is in meters per second. You have to first change this one to meters per second, to meters. So when you have to change this to meters, you are going to get 1,200. You multiply by 1,000. I hope you know that. So that will be 1,000 meters. So you have your wavelength. So after getting a wavelength, you are looking for the frequency. But you
Yeah.
know frequency. The other that I told you frequency is equal to V all over wavelength. All over wavelength. Have you seen it? I hope you remember this formula. V all over wavelength, the sign for wavelength. Have you seen this formula?
Yes, sir.
Good. So substitute it in it and let's see what you get. Use the substitution, let's see what you get.
Sir, please, I had 2.5 times 10 raised to the power 5 heads.
That's correct. Or 250 kilohertz. Okay, dude, let's do this one and see. A wave travels a distance of 80 meters in 4 seconds. A wave travels a distance of 80 meters in 4 seconds. A wave travels a distance of 80 meters in 4 seconds. The distance between successive crests of the wave is 50 cm. The distance between successive crests of the wave is 50 cm. The distance between successive crests of the wave is 50 cm. The distance between successive crests of the wave is 50 cm. Calculate the frequency of the wave. Calculate the frequency of the wave.
Sir, please repeat the question.
A wave travels a distance of 80 meters in 4 seconds. A wave travels a distance of 80 meters in 4 seconds. The distance between successive crests of the wave is 50 cm. It's 50 cm. The distance between successive crests of the wave is 50 cm. Calculate the frequency of the wave. Calculate the frequency of the wave.
Sir, 40 heads.
Correct. 40 years. Correct. Let's do one before we do another different question. The frequency of a sound wave. The frequency of a sound wave is 300 hertz. The frequency of a sound wave is 300 hertz. The frequency of a sound wave is 300 hertz. The frequency of a sound wave is 300 hertz. Calculate I, the period of the wave. Calculate I, the period of the wave. Calculate I, the period of the wave. I, the wavelength. I, the wavelength. The frequency of a sound wave is 300 hertz. Calculate I, the period of the wave. I, the wavelength.
Sir, I was what?
The
Sir,
period
please,
of the
I
wave.
was what?
The period of the wave. The period of the wave. I, the wavelength. I, the wavelength. Take the velocity of the sound wave to be 340 ms negative 1. Take velocity of sound wave to be 340 ms negative 1.
So for the period, I got 0.003 seconds. And the
Okay.
wavelength, I had 1.13 meters.
Oh, okay. 1.1.
1.13 meters.
Okay.
And the wavelength I had, and the period I had 0.003 seconds.
Okay. Yeah, correct. So we are going to do this one. A wave profile is represented by this. Calculate its wavelength, velocity, frequency, and period. Calculate its wavelength. So try. Let me see if you can do it. So you are doing it, eh? Let's see if you can do it. Are you on it? Robin, are you on
Sir,
it?
please, for the period I had 0. Sir, for the period I had 0.001 seconds.
Good. Good. And for the wavelength?
So I'm on it.
Okay.
Sir, please, is the wavelength 17 meters?
A wavelength is not 17 times 2. 17 times 2. So check, there's a certain 2 there. In your combination, there's a certain 2 there. Don't forget, it's 2 pi VT all over that's the wavelength. So when you equate it, supposed to be 2 by the distance 17 pi distance. So based on what you are doing, I don't know how you are doing it, but it's supposed to be 34 instead. So check.
Sir, please, is the frequency 1000 hertz?
Yes, the frequency is 1000 hertz. What do you get for the velocity? Are you done?
So as for the rest, there is very
So let's try it. So we will compare this to what do you call it? The main progressive wave equation, which is A sine. I don't know how you did yours. A sine, but there's A sine 2 pi. The network is misbehaving. So the main equation you were given was displacement is equal to amplitude sine 200 2000. Robin, I hope you are following. Pi t
yes, sir.
minus pi x all over 17. So when you are given something like this, you compare this to the main what do you call it, wave equation. You compare it to the main progressive equation. So when it is positive, you compare it to the positive one. This is negative, so you compare it to the negative one. So you compare it to y is equal to a sine, that is 2 pi Vt all over minus 2 pi x all over wavelength. I hope you've seen this equation. I gave you this the other time. So looking at this by comparison, we can compare this and this. We can also compare this and this. I hope you know that. So by comparison, by CM, by comparison, we can compare the whole of this and this. So we can say that this is how you do it when you're given work like this. I don't know if that's how you did it. Is that how you approached it?
So that's how I did it, but I got here, but the the this thing I was looking for, there were two variables that I was looking for. That's what confused me. So I thought maybe it's not that one.
Sorry. So when you get to this one, you know, this will cancel this. This will also cancel. So you are going to get 2000. 2000 is equal to 2V all over this. Now, even 2 can cancel this and give you 1000. So the 2 can cancel this and give you 1000. But let's just keep this. I want us to do so. Oh, you've already found the frequency, so you could have just used this to find for the frequency, but because you know frequency is also equal to V all over this. So the whole of this stands for frequency. So this is when you divide this by 2 and divide it by 2, you get 1000. So for frequency is equal to 1000. That you've already found. Now we can also do this two comparison. So we can get 2 pi, because they are both negative, so you just ignore them, it will cancel out. All over this is equal to pi all over 17. So don't forget this, we'll cancel this. So we can get 1 here. So this times this will be equal to this. So 2 times 17 will be equal to the wavelength. Have you seen it? Now I'll give you 34. Have you seen it? Have you seen how we do it? Hmm? Ruben, have you seen it? So there's the wavelength. Now we have the wavelength. We can put the wavelength here and come and find for V. And come and find for V. So wavelength is 34. So we can put the wavelength here and come and find for V, which is the velocity. Ruben,
Yes, sir.
I hope you are getting it.
Perfectly.
Good. So when we come and put the 34 here, we are going to get 34 times 1,000 because we assume 2 cancel here and give us 1,000. So that will be 32 times 1,000 times 1,000 will give us V, and that will give us 34,000. So V will be 34,000. The network is fooling today, pa. So that is it. So that will give us 34,000 or 34k hertz. Hey, that is velocity. So 34k ms minus 1. There's 34,000. Oh, the k is 1,000, not kilometers, please. Or 34 kilometer per second. That is it. You can anyhow you do it. So that is it. And the rest, I know you've already found the rest. Ruben, talk. I don't know.
Sir, please, you were buffering, so I did not get what you were saying.
He said, what?
You were saying clearly.
Which side didn't you get it? The network is misbehaving today. I don't know what to even do. I'll give you work and you do it for me, so that we will continue next time. I don't know. I'm not. But which part didn't you get it? Please tell me. But I know you understand how come we got the velocity. Do you understand how come we had the velocity? Hmm?
But on the board, wavelength and the velocity. After that one, I did not hear anything again.
So the frequency, I thought the frequency you had already solved it. That one you had the what do you call it? The 1,000
Oh,
hertz.
sir, I've solved.
Uh-huh. You already solved. So you realize that we had something like two all over this. When I was solving it, all over this is equal to 2,000. Is equal to 2,000. We had this, and I told you that the whole of this stands for frequency because frequency can also be equal to V all over this. So in other words, you can say that 2,000 is equal to 2f, where f is the frequency. So f will be equal to 2,000 divided by 2. You get it? So frequency will give us 1,000. Now, once you have frequency, you can find for what do you call it? Period. Period is 1 over f. So t will be equal to 0.001 seconds. Have you seen it?
Yes, sir.
Good. I want us to do the stationary distance, but the way the network is misbehaving, I don't even know what to do. I'm coming in. I want to send me a certain question. Good. I've sent you a question. You do that one too for me. So we spoke about the other, what do you call it? The other properties of wave. The other properties of wave. So we spoke about that. Let me clear the board. Now we are going to talk about interference a little bit. When we say interference, we are saying that it is the superposition of two waves of the same frequency and amplitude. So the superposition of two waves of the same frequency and amplitude. Other than I explain it, when you dip two balls in what they call it, or two dippers in a tank full of water, you realize that you see ripples. Now, when you see the ripples, you realize that the ripples interfere with each other because they are two. You place them simultaneously or contemporarily in the water. You realize that they will interfere. So you are going to get something like in the water. You are going to get something like this. Maybe they are all in the same water, so the same pool of water or the same tank. You realize that maybe this point A, this is where you dropped the first stone, and you also dropped the other stone here. So this point B, point A. Now you realize that when you drop them, you realize that ripples will form here. That you already know, ripples or ripples, anyhow you want to say it. So this will be the ripples of the water. Now the B will also have the same ripples of water, the same ripples here, and you realize that at a point in time they will interfere with each other. So some of the ripples will enter into this ones, some of these ones will also enter into this. Please draw it beautifully. I hope you are getting it. Have you experienced something like this before? So you get that they will interfere. Now, when this happens, we say that there's a superposition of the two waves of the same frequency and amplitude. And so there's a superposition, and when that happens, we say that there has been an interference. There's a wave interference. Do you agree? Ruben?
Yes.
Good. So that's what we call interference.
Yes, sir.
So in a region where the two waves overlap the waves, because the two waves there's an overlapping. If it was to be in football, you see there's an overlapping. And so the waves are said to be superimposed. You can also say they are superimposed. And the superposition of the two waves of the same frequency and amplitude produces a phenomenon that we call the interference. And so when they are superimposed, or the superposition of two or more waves with the same frequency amplitude, they produce a phenomenon that we call interference. And so you can define interference as the superposition of two or more waves of the same frequency and amplitude. Are you getting it?
Yes, sir.
Good. Now, when you advance the class, you realize that the displacement at any point is normally determined by the principle of the superposition. The principle of superposition. And it states that when two or more waves pass through the same medium at the same time, the net displacement of any point in the medium is the sum of the displacement that would be caused by each wave alone in the medium at that time. And so if you want to know the net displacement, it will just be addition of the two or more, the displacement of two or more waves. So if the displacement of B is equal to y is equal to maybe a sine something, and that of B is also a is equal to y is equal to this thing, that these are the displacements. Now to get the net or the resultant displacement, it will be the summation of the two of the displacements. Are you getting it? Basically, that is it. It's a law. This is a law. So, or the principle of superposition, and you have to get it. And they can ask you to state it. Let me just read it so that I write. Are you ready? Are you ready?
Yes, sir.
Good. So the principle of superposition states that the principle of superposition states that the principle of superposition states that when two or more waves pass through the same medium, so in the first experiment, they are talking about the water, which is the medium. That's one medium. So when two or more waves pass through the same medium at the same time, so we assume that you drop the stones at the same time, with the same displacement and the same altitude, or what do you call it, amplitude. So when two or more waves pass through the same medium at the same time, when two or more waves pass through the same medium at the same time, pass through the same medium at the same time. Are you there? Pass through the same medium at the same time. The net displacement of any
Yes,
point,
sir.
the net displacement of any point, 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 the net displacement of any point in the medium is the sum of the displacement. The net displacement of the medium at any point is the sum of the displacement. The net displacement at any point in the medium is the sum of displacement that would be caused by each wave alone. The sum of displacement that would be caused by each wave alone in the medium at that time. The sum of displacement that would be caused by each wave alone in the medium at that time. Are you there?
Yes, sir.
Good. So it's as if you are tired like that. I don't know. So
So your network.
okay. Then let's end so that we continue the other time, the next time, so that it won't be like you didn't hear anything I told you. So please do the work I sent to you on the platform.
Okay. So, sir, please upload this thing on YouTube.
I hear I will.